All right, ready to dive into some serious vintage computer tech? We're talking the ANUYK, a computer designed for Navy warships in the 1960s. Can you believe that?
That's right. And it's more than just a historical curiosity.
Oh, absolutely. This thing was way ahead of its time. We've got declassified user notes, a study guide, and even the original technical manual. We're going deep.
Yeah, it's amazing what they accomplished back then with the technology they had.
So get this, the UYK-1 used something called stored logic, which is basically the foundation for the software-driven world we live in today.
It was a pretty revolutionary concept for the time.
Okay, so paint us a picture. It's the 1960s, you're on a Navy ship. Where's this computer? What's it like?
Well, first of all, it's surprisingly compact, only about 5 feet tall and a couple of feet wide. Space was limited on those ships.
5 feet tall. That's still pretty big. I mean, I guess I'm thinking about modern computers, but still.
Oh, for the time, that was considered small, especially for a computer that was powerful enough to handle the demands of a warship.
That's true. They had to fit it in alongside all the other equipment.
Exactly, and it had to be rugged enough to withstand the harsh environment of a ship at sea.
So this was no delicate piece of machinery.
Not at all. It was designed to be reliable under pressure, no matter what the conditions.
So we've got this compact, rugged computer tucked away somewhere on the ship. What was its main job?
Well, one of its primary functions was to work with the Navy Tactical Data System, or NTDS.
Right, the NTDS. It's their network for sharing tactical information. Yeah.
Exactly. So the ANUYK-1 was a key player in keeping everyone connected and in the loop, sharing crucial information about the battlefield.
Okay, so we've got this computer that's tough, it's compact, and it's connected to this vital network. But how did the sailors actually use it? Did they need to be computer whizzes to operate it?
You know, that's what surprised me when I first started digging into the sources. You didn't need a computer science degree to use this thing.
Really? That's surprising, especially for technology from the 1960s.
It really is. They designed it to be surprisingly user-friendly. They got rid of all the unnecessary complexity and used familiar controls like toggles, switches, and indicator lights.
Hmm. That's interesting. So they basically took inspiration from the ship's existing equipment.
Exactly. The sailors were already familiar with those types of controls, so it made the transition to computers a lot smoother.
It's like they were trying to make it as intuitive as possible.
Exactly. And that ease of use is actually directly tied to this stored logic concept that you mentioned earlier.
Oh, right. The revolutionary idea that basically paved the way for software as we know it. Tell me more about that. How does user-friendliness connect to this concept of stored logic?
Okay, so imagine this. Instead of having fixed hardware for every single task the computer needed to perform, they used software to change its functionality on the fly.
So it's not like they were physically rewiring the computer every time they needed to do something different.
Exactly. And that's where the stored logic comes in. They used software to define what the computer could do, which made it incredibly adaptable. It's like having a toolbox with one tool versus a toolbox where you can swap out tools depending on the job.
That's a great analogy. So stored logic essentially means that the computer's functionality could be changed through software without having to physically alter the hardware. That's incredible.
It was a huge breakthrough, and it really laid the groundwork for what we now call software-defined systems.
And this approach made the NUYK-1 adaptable not only in terms of tasks, but also in the types of data it could handle.
Exactly. It wasn't limited to just one type of data. The NUYK-1 could work with different word lengths, 15, 30, or 45 bits, and different data types, fixed point, floating point, you name it.
Wow, that's pretty impressive for a computer from the 1960s. It sounds like it could handle numbers, text, and even complex calculations.
It was a truly versatile machine, ready for whatever the Navy threw at it.
It's hard to believe they were doing all this back then. It's like they were already envisioning the world we live in today where computers are everywhere and do everything.
It really was a glimpse into the future. The NUYK-1 was a small but significant step in that direction.
So we've established that this thing was adaptable and user-friendly, which is amazing considering the era. But was it fast? I mean, we are talking about the 1960s. Did it keep up with the demands of a naval battle?
Well, about that speed. Prepare to be impressed. The manual states that the NUYK-1 could search a 1,000-word table 5 times faster than the most common large-scale computer of the time.
Hold on, 5 times faster. That's mind-blowing.
It really is. And that kind of speed was crucial in a naval battle where decisions had to be made quickly.
Absolutely. They couldn't afford to wait around for the computer to catch up. So how did they achieve that kind of speed?
Well, it was partly due to the innovative way they designed their software. They created specialized instructions, kind of like shortcuts, for common tasks. They called these logands. Think of it like having a dedicated lane on the highway for certain types of vehicles. It just speeds things up.
Logan's, that's a new one. So these Logan's were basically optimized instructions that made the computer run more efficiently?
Exactly. They were designed to handle common data processing tasks, like moving blocks of data, searching tables, and comparing values.
So they were thinking about efficiency from the ground up, both in terms of the hardware and the software.
They had to. Space and resources were at a premium on a warship, so they couldn't afford to be wasteful.
It's amazing how they managed to pack so much power into such a compact and efficient machine. It's like they crammed a supercomputer into a closet.
And it wasn't just about cramming it in. They also had to make sure it was built to last. The UYK-1 was designed with maintenance in mind. Remember, they used modular components, so if something went wrong, you could easily swap out the faulty part without having to take the whole thing apart.
So it's like building with Legos. If something breaks, you just replace the broken brick. Genius.
Right. It simplified maintenance and made the computer much more reliable in the long run.
That's so important, especially in a harsh environment like a warship. You need a computer that can take a beating.
And remember the stored logic concept we talked about? That actually simplified troubleshooting too. Since most of the complexity resided in the software, diagnosing problems became a lot easier. It's like being able to fix your car by simply updating its software instead of taking the whole engine apart.
Okay, I'm getting the picture now. We've got this compact, rugged computer that's easy to use, surprisingly fast, and built for easy maintenance. But how did they make it work? How did they actually program this thing to handle the complex demands of naval warfare?
Well, that's where it gets really interesting, and that's what we're going to explore next time.
All right, I'm already hooked. Can't wait to hear more about how they programmed this 1960s computer to be a naval powerhouse.
It's a fascinating story, and we've got plenty more to share. Welcome back. Last time, we were just about to delve into how they programmed this 1960s computer for naval warfare.
I'm ready to have my mind blown again. I mean, it's hard enough to grasp how they built a computer that powerful back then, let alone how they programmed it for such a complex task.
It is pretty mind-blowing, especially when you think about the limitations they had. But they were incredibly resourceful.
Okay, so let's get into it. How did they make this computer a naval powerhouse?
Well, first of all, they started with a solid foundation. The UYK-1 was built using transistors and other solid-state components, which were the cutting edge of technology back then.
Ah, so no clunky vacuum tubes taking up half the ship.
Exactly. Transistors were much smaller, more reliable, and more energy efficient, which was crucial for a shipboard computer.
Right, every bit of space and power mattered on those ships. So transistors were a big step forward in terms of hardware, but what about the software? How did they program this thing to handle the demands of naval warfare?
That's where the magic of stored logic really comes into play. Remember those logands we talked about, those specialized instructions?
Yeah, the computer's shortcuts for common tasks. How did they use those to actually create programs for naval warfare?
Well, they could use those logands as the basic building blocks, combining them into sequences called lograms, which were like mini programs within the larger system.
So logan's are like individual Lego bricks, and lograms are like the structures you build with them.
Precisely. And by combining these lograms in different ways, they could create incredibly complex programs that could handle all sorts of naval tasks.
Like what kinds of tasks? Give me some examples.
Well, for example, they could program the computer to calculate the trajectory of a missile, track the movement of enemy ships, or even help coordinate attacks involving multiple ships.
Wow, that's incredible. So they were essentially creating the software equivalent of a naval strategist.
Exactly. And they were doing it all in real time, processing information and making calculations on the fly.
Wait, real time? They didn't have time to stop and reprogram the computer in the middle of a battle, did they?
Nope. The UYK-1 had to be able to keep up with the ever-changing conditions of a naval engagement. It's like having a conversation where you have to respond immediately to what the other person is saying.
That's a lot of pressure. How did they make a computer from the 1960s so responsive?
They used several clever techniques. One was parallel processing, where they basically divided the work among multiple parts of the computer, allowing it to handle multiple tasks simultaneously.
Ah, so it's like having a team of people working on different parts of a project at the same time.
Exactly. And they also used something called interrupt handling, which allowed the computer to prioritize tasks and respond quickly to unexpected events.
Interrupt handling sounds intriguing. What's that all about?
Think of it like this. You're reading a book, and suddenly the phone rings. You have to interrupt your reading to answer the phone, and then you can go back to your book.
Okay, I get the analogy. But how does that apply to a computer?
Well, in the case of the UYK-1, it meant that the computer could be in the middle of a task, like calculating a target's trajectory, and then suddenly an alert comes in, like a new radar contact, and the computer has to switch gears immediately to handle that new information.
So it's like a built-in priority system, making sure the most urgent tasks get handled first.
Exactly. And that was crucial for a naval computer that had to be able to respond quickly to changing conditions in the heat of battle.
It's amazing how they were able to anticipate these needs and design a system that could handle them.
It really is. And they were doing all of this with technology that seems incredibly primitive by today's standards.
Okay, so we've covered how they programmed the ANUYK-1 for naval tasks, and I have to say, I'm impressed. But there's one thing I'm still curious about. We know that sailors use those toggle switches and indicator lights to interact with a computer, but what about the programmers? How did they actually input those complex programs?
Well, it wasn't as simple as typing on a keyboard like we do today. Remember, this is the 1960s.
So how did they do it?
It's a bit hard to say for sure without more specific information from our sources, but it's likely they used some form of symbolic language, kind of like an early version of assembly language.
Symbolic language, what's that?
Well, instead of writing code in a way that we would recognize today, they would have used symbols and abbreviations to represent the different logands and their functions.
So imagine lines of code filled with cryptic symbols and abbreviations, maybe even handwritten on punch cards.
It wasn't the most user-friendly way to program a computer, that's for sure. But it was the best they had at the time.
It's amazing to think that they were able to create such a sophisticated system using such primitive tools. It really makes you appreciate how far we've come.
It does. But it also makes you respect the ingenuity and dedication of those early computer programmers.
Hmm.
They were true pioneers in their field.
Absolutely. Okay, I think we've covered a lot of ground in this deep dive. We've explored the ANUYK-1's design, its capabilities, its impact on the Navy, and even the challenges of programming it. It's clear that this was a groundbreaking piece of technology, a true pioneer in the field of computing. But I'm curious, what about its legacy? How did this computer influence the development of subsequent systems?
That's a great question, and one we'll explore in more detail in our next segment. But for now, I think it's important to remember that the NTDS-1 wasn't just a standalone computer. It was part of a larger system, the Navy Tactile Data System, or NTDS.
Right, we mentioned that earlier. It was their network for sharing tactical information. But how did the ANUYK-1 actually contribute to this network?
Well, it played a crucial role in processing and analyzing the vast amounts of data that were flowing through that network. Remember, this was a time when computers were still relatively new, and the idea of using them to manage and interpret real-time combat information was revolutionary.
So it's like having a central brain that could make sense of all the chaos of a naval battle.
Exactly. The NUYK-1 could take in information from radar, sonar, other sensors, process it all, and then display it in a way that was meaningful to the ship's commanders, giving them a much clearer picture of the battlefield and allowing them to make better decisions faster.
So it wasn't just about having more information, it was about being able to understand and act on that information effectively.
Precisely. And the NUYK-1 was instrumental in giving the Navy that edge.
So the ANUYK-1 was a key player in the NTDS network, helping the Navy make sense of the chaos of battle. But how did it actually change the way they fought? Did it lead to any tactical advantages?
Well, that's a question we'll dive into next time. But I'll leave you with this thought. Imagine trying to fight a modern war without computers. It would be nearly impossible. And the ANUYK-1 was one of the first computers to be used in this way, paving the way for the information-driven warfare we see today.
It's amazing to think that a computer designed in the 1960s could have such a lasting impact on the way we fight wars. It really makes you appreciate how far technology has come.
It does. But it also makes you wonder how much further we can go. If the ANUYK-1 was such a game-changer back then, what will the computers of the future be capable of?
That's a question for another day, perhaps. But for now, we've got to wrap up this segment of our deep dive. Join us next time as we explore how the ANUYK-1 actually changed the game of naval warfare. You know, we've talked about how revolutionary the ANUYK-1 was, but I'm still curious about something. We know it was built to be compact for a warship, but how compact are we really talking? Did they ever mention the actual weight of this thing?
That's actually a really good question. It's funny how our sources go into so much detail about the design, but they don't mention the weight at all.
Right. It makes you wonder if maybe weight wasn't as big of a concern back then as it is today.
I think you're onto something. We're so used to miniaturized technology now, But back then, robustness and functionality were probably the top priorities.
Yeah, maybe they weren't too worried about how heavy it was as long as it could survive the rough seas and do its job.
Exactly. They weren't exactly thinking about portability like we do with laptops or tablets today.
It's like the difference between a rugged off-road vehicle and a nimble city car, right? Both will get you where you need to go, but they're built for completely different purposes.
Perfect analogy. The UYK-1 was built to be tough and reliable, even if it meant sacrificing some portability. They needed a workhorse, not a show pony.
It really puts into perspective how much computing technology has evolved. We've gone from these big, heavy machines to devices that can fit in our pockets.
It's amazing, isn't it? But it's important to remember that those early computers, even the ones that seem clunky by today's standards, laid the groundwork for everything we have now.
Absolutely. They were the pioneers, figuring things out as they went along.
Trailblazers, for sure. Speaking of figuring things out, I've been wondering about something else. We've talked about how user-friendly the UYK-1 was for the operators, with its toggles and switches. But what about the programmers? How do they actually create those logands and lograms? That sounds pretty complex.
Yeah, it does. The sources mentioned they had tools to help them, kind of like early versions of the software we use to write code today. But did they have anything resembling a modern programming language?
Well, the sources are a bit vague on the specifics. They talk about how programmers could work directly with the logans for the most basic operations. But for more complex instructions, they'd use those lograms, the sequences of logans.
Right, like combining building blocks. But how did they actually write those sequences?
It's likely they used some kind of symbolic language. It would have been a way to represent the logins and their functions, but probably very different from the languages we use today.
So picture this. Lines of code filled with cryptic symbols and abbreviations, maybe even handwritten on punch cards.
Definitely not as user-friendly as the graphical interfaces and intuitive languages we have today. Programming back then was a much more specialized skill.
It makes what they accomplished even more impressive, doesn't it? They were basically inventing the tools and techniques as they went along.
They were, and they still managed to create this incredibly complex system that was, in many ways, ahead of its time. It's really remarkable.
It makes you wonder what they would think of the computers we have today. They'd probably be amazed by how far we've come.
I think so too. But I bet they'd also be thrilled to see how the principles they pioneered are still at work in modern computing.
Well, I think we've squeezed every last bit of knowledge out of these sources about the UYK-1. It's been an incredible journey.
It really has. Who knew a computer designed for warships in the 1960s could be so fascinating?
It just goes to show that there's always something new to learn, even from technology that's considered obsolete.
Exactly. The UYK-1 may be a relic of the past, but its story is still relevant today.
Absolutely. And I think it leaves us with a lot to think about. The power of innovation, the importance of adaptability, and the legacy of those early pioneers who dared to push the boundaries of what was possible.
Couldn't have said it better myself.
So, to our listeners, we encourage you to keep diving deep, keep questioning, and keep exploring. The world is full of fascinating stories waiting to be discovered.
And who knows? Maybe you'll be inspired to create the next groundbreaking technology.
Until next time, keep those minds curious and stay tuned for more deep dives into the world of knowledge.